Hello, everybody. My name is Grzegorz Pietrzak. I work here in DrupalCamp, and today I will tell you a few words about dependency injection. This will be a tale, so there will be some story. I will tell you about how it all began, how to use it, why exactly is it in Drupal, and what's the actual feature of dependency injection. My lecture is for intermediate users, but I hope that everyone will take something out of it, because I will talk about simple things and also more complicated ones. And I will start from simple things, actually. I want you to forget for a moment about Drupal Symfony, to focus on a really simple example of dependency injection to understand why exactly do we need it. So I will start with something that we shouldn't do in programming to explain you why exactly dependency injection is so cool. So our example here is to show you how we code in the past, and actually maybe not even in the past, because in Drupal 7 we still do such code. We use a lot of globals, a lot of objects from global scopes. So some time ago we coded like this. So we created functions. We were reaching for some globals. This code looks really simple, I suppose, really clear, but it has some really major disadvantages. And I see three problems here that are most problematic. So first one, we rely on global state here. So we are reaching from local context to global context. We have some local function that reaches out for some global database. This function doesn't even know if this database is instantiated, if actually this database can be called right now. So we rely on some environment, and we don't know anything about it. The other example is when you have the super globals like get or post, and you try to use it in the CLI environment, and you don't have them. So this is called relying on global context or global state, and in modern programming, this is highly discouraged. The second problem here is that this function is a liar, because it says, hey, I have no arguments. You can call me anywhere. And it's not true, because actually this function has dependencies. And if you call it from some external code, this external code have to know if the database is instantiated. So on one hand, the code is clear, but on the other hand, it's not. So to have full clarity, we have to know the dependencies here. And third thing about this code is that it is really hard to debug. So imagine that this database gets overridden somewhere, or it's not instantiated yet. It's really hard to track such cases. And also, if you would like to mock the database to create a unit test of this function, there is no way, because you are reaching for globals inside. So these are the main disadvantages here. You can rewrite this code slightly into object-oriented programming. And here's the second anti-pattern. We create some class. In this class, we have a constructor that creates the database. So theoretically, it solves the problem with global, because we know the database is created here. So we are not reaching for some global context that may not be instantiated. But on the other hand, this user class, that is some local class, has to know how to create a database, and this database creation could be moved somewhere else out of here. So the example is not perfect. And also, if you would like to unit test this class, it's not really possible, because database is called from the constructor. You cannot inject any test database there, some class that is returning fake data. You just have it hard coded in your code. So in short, these are the reasons why we should use something like dependency injection. Dependency injection is a design pattern. It's not very new actually, but it came to us, to Drupal users, in 2015. So how to use dependency injection while using the examples that we had before. So we rewrite slightly the code, the object-oriented code that we had on the previous slide. We add a parameter to the constructor, and we inject the database into it in our main code. So the database is not created inside our class, but it's passed to it while constructing the object. So the advantage here is that this user class doesn't have to know anything about database creation. It gets the database injected. You can inject either a database or some mock database or anything else that is compatible with the definition. So if you have some interfaces, you can create a very elastic solution here. This code is very clear, even if it's a bit verbose. It's clear because if people know how to use dependency injection, how it looks, and it's like a standard in PHP world right now, they will know instantly what happens here. And also, this code focuses on local context because it focuses on object that is passed to the class. So this database can actually be something more local than some super class that holds the database. I put some links in my presentation so you can check the sources. There are a lot of cool examples here how to use dependency injection, how to relate it to some situation in coding. Here I'm just showing you some very simple examples. We can separate few roles in dependency injection, and I was looking for a very long time for some real life example of dependency injection, because if you have factory, you can relate it to some real life factory, but in dependency injection it's kind of hard to imagine. So Wikipedia gives us a really cool real life example of a kid who wants to drive a car. So the kid says to the parent, I want to drive a car, but I can't. I don't have a car. Let's arrange that. So in dependency injection, we can separate some roles, as I said. There's the client class. In this case, our kid, our new driver. There is the service class that needs to be used in the client class. So it needs to be injected into the client. And in our case, this is the car. The car can be hybrid, electric, diesel, but if you learn how to use the car interface, which have a gear shift, pedals, steering wheel, levers, and so on, you actually know how to drive all those cars. So the car has an interface, and there's an injector that is the parent. So the parent handles everything here. And if you look at some code, our service object is a car, in this case Volvo, because the parent said that Volvo is cool and safe. We have driver that has a constructor to inject the car, that has a function drive to start, to turn lights, to put some gear on, to ignite the car. And we have the injector that creates, in this case, maybe buys a car, that creates a driver, injects a car into it, and tells them to drive. In this example is kind of weird, but it's really hard to put the dependency injection into life. But why do I show it? Because in this case, imagine, for example, that we want to test the kid's abilities to drive. So we don't actually have to buy a Volvo. We can buy an Xbox with a steering wheel and tell the kids, drive, show me that you can do it. And also the kid doesn't have to know anything about buying a car or maybe getting a driver's license. It's just the kid is instructed by the parent. In more advanced examples, actually we don't have the injector like this. We have a dependency injection container, which takes care of service creation, of service class creation, and probably the parent wouldn't have to know so much about buying cars or sending kids to driving schools. The parent would just tell the container, dependency injection container, to handle everything. I will show you later on examples how easy that is. So to sum up this first part, why do we use dependency injection? First thing is separation of concerns. So if you use it for some time, if you really know how to use dependency injection, you notice that your classes became clearer and clearer, that they have separated functionalities. They are small. They are really like doing one thing and not everything. So you separate the concerns in your code, and the code, because of that, is more readable, is reusable. The last thing I mentioned here, to support different configurations, this matters more for languages that need compiling, because in this case you don't have to recompile the code to support configurations other than standard. In PHP it's maybe understood in a different way, but generally this stuff comes out of the dependency injection of its usage. So I promised you a tale, so I will speak a bit about history of dependency injection. And this history is tied to the history of object-oriented programming. I prepared some timeline to show you that dependency injection is not really a new idea. It has been with us for over 20 years. And the history of dependency injection is tied to the history of Java. So I won't speak only about PHP, but I will put it in the context of all programming languages. So the timeline starts at 1965. This was a very important year for programming because Simula language was released. It was the first object-oriented programming language that contained all the ideas that we have now. So object classes, inheritance, dynamic bindings. And this language became a starter for other object-oriented programming languages like C++, that was released in 1985. Object-oriented programming ideas were growing, were more and more complicated, and the date of 1994 is also really important in programming world, because back then 4 PHP gurus that named themselves Gang of Four released a Bible of programming. It was called Design Patterns, and this book changed like everything about the programming that we know now. Everything that was maybe not everything, but it cleared many topics. It described best practices, best solutions that were out so far. There were no dependency injection or dependency inversion or solid back then, but there were some fundamentals to the ideas that appeared later. And in 1996, finally, the Java 1.0 was released. It was a milestone when we talk about dependency injection or OOP programming in general. In 2000, solid rules were formulated. in 2002, Spring Java framework was released. And I would say that 2002 is the most important year here, because Spring framework was something like Symfony to PHP. It introduced dependency injection to Java. Previously in Java, we had a lot of factories, a lot of global singletons that were reaching for some superclasses. After Spring, everything changed. So we had the first framework that used modern dependency injection to inject services into classes. And other frameworks came, were basically based on what Spring did. Spring is, of course, out also today. There were a lot of new versions of it. And in PHP world, a similar date to 2002 is 2011, when Symfony 2.0 was released. I will tell in a moment why I don't talk about Symfony 1.0. I have a few slides about it. And of course, in 2015, we had Drupal 8 that also changed everything in Drupal world. So we can say that dependency injection is with us for those 20 years after Spring release, maybe a bit before, because it was the idea was growing. About Symfony, the real dependency injection was introduced in Symfony 2.0. I don't know how many of you used the Symfony 1, because Symfony 1 was based off something named SF context. It was kind of a singleton. If you reached for SF context instance, you could get all the major services of Symfony, so database and so on. It was considered very modern, and I remember that Symfony was also considered very cool and rapid because of this. But it was this SF context was not enough, and Symfony creators turned to the same direction that Spring, and basically next versions of Symfony were highly based on what Spring did. In Symfony 1.2, the dependency injection was present in core classes. It was easier to test them, easier to develop. And finally, in Symfony 2.0, there was a small evolution. Everything was dependency injection. All services were moved to dependency injection container. And it looks pretty much the same as in the modern Symfony. So no more singletons, no more old patterns. We use dependency injection almost everywhere. So we turned from global contexts to local ones. In Drupal, it was more of a revolution than evolution. As we all know, in 2015, the 7 version was replaced by version 8. Version 7 had a lot of procedural code, function hooks, PHP theme templates, globals, as we talked in the first example of bad practices. And all of this was changed, maybe not all, but most, into Symfony components, routing, dependency injection container, events tweak. It was kind of a big revolution. And everybody knows this image from about learning Drupal. So the learning curve for popular CMSs looks like this. Drupal is really hard. And after version 8 release, when dependency injection was needed everywhere, people were not really happy about what happened. I've searched for some opinions back then in Google. So here are some of them about dependency injection. So maybe somebody will use it. So it's good only for unit tests. Or in theory, you can parameterize any class instance, but in real world, you never need it. People were not very happy about Drupal 8. And the result was creating of the backdrop CMS that is a mix of Drupal 7 and Drupal 8. And all those controversies are coming back right now because Drupal 7 is reaching end of life, and many sites are staying with Drupal 7. Many sites are migrating to 8 or 9. So this dependency injection and other stuff, other new stuff issues are still with us. Okay, now I wanted to show you how to use dependency injection in Drupal. It's a more practical part, I would say. I tried to gather all the ways to do it. I hope I managed to. If not, please write to me and correct me. Dependency injection in Drupal is mainly using the service container. Drupal consists of services since Drupal 8. The services are some classes that do some separated functionalities. You can get them exactly like from the global scope, but they are created by the service dependency injection container. Each service is declared either in the YML file or by the PHP service provider class. So you can actually look what services you have by searching for the YML files or looking into Drupal.org documentation. And I wanted to show you how to use dependency injection on the example of language manager. It's some core class that is managing languages. It's declared like this in core. If you ever need to declare your own service, you do it in exactly the same way. So you define some label, some class with the namespace and arguments that are passed to this service. I will show you in the moment. The arguments are actually the labels. So if we had a language manager class to be injected into our service, we would call it by arguments at language underscore manager. All those defined services are put into the service container, and the trick is to know how to get them out of there. So how to get services from the container in Drupal? First method, the easiest one actually, but also highly discouraged, is to use the Drupal class. There is a static method service. There are some predefined static methods like language manager. You can just call it from any place of the code and get the service. It's discouraged because by doing it, you give up on some dependency injection features like testability. But when talking about Drupal, we all know that there are a lot of places with procedural code when we actually cannot inject classes. So in some cases you can use it, it's fine. If you have too much of such code in your functions in your model files, you probably have to move the code to the classes or create some custom service. It's a sign of not really great code. Second method of using dependency injection, even also highly discouraged, is to implement ContainerAwarelnterface. When we talk about mistakes that are done by beginners in Drupal, I would say ContainerAwarelnterface is very high on the list. By using this interface and trait connected to it, so container-aware trait, you can actually put the container as a property of your class. And from container, you can get any service in Drupal. This method is not really recommended because in this case, you cannot inject, you are not injecting classes, you are just injecting a container. So the effect is you cannot unit test the class, and you lose all the elastic features of dependency injection here. But in some cases, of course, you can use this method. For example, if you look for the container-aware interface on Drupal.org, you will notice that a few classes actually implement it. And it's mainly in cases when you need dynamic service IDs. So you don't know the ID at the beginning, it's obtained from somewhere. So you need the container to actually get this service. So this is sometimes it's used. Right now, I showed you two anti-patterns, and this is the proper usage of dependency injection that is really encouraged and that you should use. So this is simply injecting services to classes. Assume that you create some class foo and you want the language manager inside. You create the constructor, put this language manager as a parameter, and then tell the dependency injection container to inject this language manager into the class while creating it, right? So you put your custom .foo service in the services YML file in your module, then point it to the class foo, and give some arguments. In this case, there is one argument that is language manager. This syntax is really verbose, and people complain about it that classes are extremely big because of dependency injection. I presented you a shortened version, of course, but there are also comments above the constructor, above properties about the class. So on one hand, it's verbose, but on the other hand, if you know dependency injection, if you used it, you will notice why it looks like this, and it's really readable. Of course, this way is not always possible. For example, if you have forms, controllers, some other classes like constraint validators, you have to do things differently, because those types of classes cannot be actually services from the service container. So previously we were talking mostly about creating our own service. Here we are talking about using dependency injection in classes that are not services. So if you have form or controller, you implement the container injection interface, and the factory that creates this the object of this class uses the factory class create, puts the container into the parameter of this function, and this function takes care of creating the actual class. If you are concerned about using the container here, as we talked before, it's usually it's not recommended to reach for the container. In this case, it's perfectly fine, because if we would like to unit test this class, we just create the foo, the object of foo class by calling the constructor, and inject what we need to as the parameter. So actually, this works really good, and there are hundreds of examples of such usage of container injection interface. For some classes, this won't work. For example, if you want to inject some service into plugins, plugins in Drupal have different definition of constructor. They need more parameters. So the standard interface that I showed before won't work here. There's a modified version that is called Container Factory Plugin Interface. And as you can see, the usage of it is not very easy. But on the other hand, when you have like a nice code not fit into a presentation, it looks really clear and has all advantages of the dependency injection. So these are all methods of accessing services that I found. Maybe there are a few more. Please correct me. So the last thing I wanted to say is the future of dependency injection, because I already said that dependency injection lives with us for about 20 years, maybe more. And there is also a bright future ahead because when you, for example, develop in Symfony, you see that the usage of dependency injection is much easier, and we are all waiting when Drupal gets all those functionalities. First and most important thing is autowiring. In Symfony, it's present since 2015, so actually very close to the release date of Drupal 8.0. In Java Spring, it was introduced in November 2007, so a long time ago. And autowiring is a method of simplifying all the things that I showed you, so defining the services and using them inside classes. And assuming that dependency injection works in Drupal in the same thing that works in Symfony, we could simplify our service definition in this way. So instead of defining some service label like language manager, instead of passing the arguments in the YAML file, we could just write the class name here and put a parameter autowire true. So the framework takes care of everything else. What's more, if you have, for example, a controller in Symfony and use some class, some service as a parameter of the action of this controller, it gets injected automatically. So you don't have to define anything; it just works. So if you use this language manager or something like this in Symfony, you don't have to maintain in few places of code the definition of it. So it's really helpful and helps keeping the code clean. What is surprising, Drupal has some support for autowiring. The support was introduced in Drupal 8, and more or less it worked. There were some, as Drupal org guys said, some hacks that made autowiring possible. You could use it in your custom classes. In Drupal 9, all those hacks were removed. If you want to use autowiring, you have to create a service provider. This is a class that translates class names to service IDs, and those service providers are usually quite big classes, and you may not want to see them in your code. And a very good news is that in Drupal 9.3, that is coming in December, there will be a full support of autowiring. So slowly we are going towards a situation where creating services, maintaining them is much easier. There's also a plan to convert all core services to use autowiring. It's not easy because there are a lot of core services and you have to test them to check if everything works. So I guess until December we won't have it. This is something for the future. But hopefully very soon we'll have all the functionalities that Symfony provides also in Drupal. And the second thing that is about the future is PHP 8. Maybe you noticed that in PHP 8 there is a new syntax for constructors. So you don't have to declare a class property outside of constructor. If you declare it inside, it will be automatically assigned to, as you can see here. So 3 lines becomes 1. The language manager is assigned to the property while injecting it and creating a new object. So it saves us a lot of code, and if we have comments above the constructor and above the property, it's also shortening a lot here. Hopefully this will become a standard in the PHP world and also in Drupal. Okay, so I guess that's all. Thank you very much for your time. If you have any questions related to DI, I will be happy to answer them. I'll wait for a while because there is a huge lag here. Okay, they started to appear. Okay, but if you have no questions, then thank you again. And if oh yes, of course, we will share this. Yes, yes. I will write it in the chat right away where to get it. Konrad, it's really a good question. And the problem is those services are scattered in a lot of YML files, and sometimes it's really hard to find one that you need. So Autowiring, I hope it will change a lot of things here, because you won't have to use some service ID. You will just use the service name in those YML files. It will solve some problems with constantly searching for service names. But the service list is also available on Drupal.org, so more or less you can find the list. Okay, checking Q&A. You know, if you ask Martin about how often do you see dependency injection not used in Drupal 8 code in PL projects, if you mean Polish projects, I didn't have occasion lately to work with Polish projects, but generally people tend to use dependency injection in the wrong way. So use the Drupal class or this container aware interface. So actually we fixed a lot when we get some code to audit. Like the knowledge about dependency injection is not very common, and there are also a lot of wrong examples on Stack Overflow and other places. Okay, so if there are no other questions, that I guess, thank you very much and see you on next DrupalCamps.